going to approach another key area of interest. Wozik just mentioned it in his talk. It's the incredible potential of quantum computing to revolutionize ecology and sustainability. For the upcoming panel discussion, I'd like, ladies and gentlemen, to invite on stage Head of Capgemini's Quantum Lab, Julian van Velzen. We also have with us the CTO of Genci, Stéphane Requena. We have the founder of Blaise Pascal Advisors, Etienne de Rocquiny. And finally, let's welcome back Krisztian Benyo, technical business developer at Pasqal, who will moderate again this dialogue. Thank you to the four of you.
Awesome. Thank you very much for being with us on this very, very exciting and rather new topic. So first of all, I wanted to take a minute to talk about recently launched actions by Pasqal to promote the green aspect or the green potential of quantum computing. Indeed, last year we have launched a series of actions kick-started by the Blaise Pascal Regenerative Quantum Challenge, in which all three of you and your teams were actively involved, and we are very thankful for that. Followed by Pasqal obtaining the Climate Supporter title for the 2023 United Nations Climate Change Conference, which led to the release of our joint white paper towards regenerative quantum computing with proven positive sustainability impact. However, this wasn't the first initiative in this field. Indeed, for instance, the Quantum Energy Initiative has been launched back in 2022, who has at heart representing this energy efficient or potential carbon footprint analysis related to quantum computing. With this respect, so Stéphane, being a representative of a major HPC high-performance computing player, would you mind sharing with us your thoughts about such initiatives fusioning green and emerging technologies such as quantum?
Yeah, thanks. So a few words about the Quantum Energy Initiative. So it has been launched, as you said, 2 years ago by Alexia Ofevre and Olivier Zrati and others. Now it's gathering, let's say, around 400 people in 56 countries. So it's a global initiative for addressing, as a first day, and mastering energy efficiency when the computing system are going to scale. So you saw the roadmap. We are at the level of hundreds of qubits. Quite soon, we are going to have thousands, hundreds, millions of qubits. So we want to master from the first day energy efficiency. So I will talk a bit about what we do at Genci. So Genci, we are the French HPC agency. We are in charge of what providing every day to researchers from academia and industry access to supercomputers, classical computers, for their needs in numerical simulation, big data, artificial intelligence. And so every day we are addressing this need of 4,000 users on 3 supercomputers hosted by CA, CNRS, and universities, 3 times 2 megawatts at this stage, so 6 megawatts. In the future, we are working with CA, with also EuroHPC in Europe, for the next generation. So in 2 years, we are going to install a machine of 20 megawatts. So you understand, as when we are going to pay the bill, and also as a single citizen, why it's important for us to master energy efficiency while maximizing the science we produce. So that's why we are part of the Quantum Energy Initiative. That's why also it's important to be active on the first day, to master and to be able to provide our insight to the quantum community, how we master on the classical side energy efficiency, from the single components to the application. And I will talk later about what we do in quantum, but it's really important because we think that there is a common future between HPC and quantum. It's really important really to master this energy efficiency at a systemic point of view.
Yeah, thank you for that. Indeed, one of the important aspects when we are talking about the energy efficiency of quantum computing is having a sort of a life cycle-based approach to understand not just how much your machine consumes, how much will it consume when it's being deployed in various use cases. So understanding this carbon footprint impact over the course when you have to deploy these use cases. It was a major part of the analysis we carried out during our white paper. In general, Etienne, would you mind sharing us a little bit about the positioning we took with our joint effort?
Yeah, thank you, Krisztian. I think the general issue is about purpose. You know, we're here in an event with a lot of tech enthusiasts, but if you go outside here, there's a question today about why do you wake up in the morning? And what about you would be proud with your children, with the changing world, and of course with the big challenges with the climate in general. And that tends to be a key issue if you want to build leadership. And, you know, leadership is about the story about Pascal, of course. And how do you get the best talents to join, to wake up in the morning and give the best of their life into an adventure? And there's the issue about what purpose you give. And that's where I think Georges, we discussed together and had the courage to say, let's go for the sustainability hypothesis. It's still a hypothesis, but let's take it. And we want to do this in a consistent way. You know, when we talk about purpose, you're not just talking about something which could be like greenwashing. So you want to have the general idea about the quest for sustainability. And that means looking at the use cases. Which are those use cases that would be truly helping moving into sustainability, not just putting some green thing on, you know, a tech object, but saying how can we serve climate change? How can we serve the use of water scarcity? How can we optimize the energy networks? So there's the issue about choosing the use cases and doing that in an accountable way. So that's why we connected to the United Nations SDG, Sustainable Development Goals, that tend to be a sort of a benchmark. Of course, it's an imperfect benchmark, but it's a recognized benchmark among many people, like investors, of course, and possibly coming the regulation, CSRD in Europe, and all kind of regulation. So getting a strong reference to say, really, we think this kind of use case is going to serve sustainability. And then you have to look into, well, in a life cycle analysis way, and not just in efficiency for powering the computation, which is, by the way, how the Green 500 benchmark works today. It looks only into energy efficiency when you're operating machine. And we said we want to do this in a consistent life cycle analysis way. So we push out this Green 500 and want to set a new standard. And so we started to assess the life cycle carbon emissions to actually build a quantum machine. And the good news is that the neutral atoms is way fewer tons of carbon to build it than any sort of different computers so far. And then there's a question for the future: how can we scale this and scale with a low fabrication carbon emission? And then, of course, there's the question about how many tons do you emit with the kind of algorithm that will be computed in an efficient way. And we try to open it with a hackathon, but of course it was just a start. And there's a lot of things to do to prove that we can actually compute those things using less energy than the classical benchmarks.
Thank you for that. Yeah, indeed, as you mentioned, use cases play a significant role, especially in this life cycle analysis approach. So now I turn our attention to the quantum lab of Capgemini, who hasn't been inactive in exploring various use cases, be it in a more collaborative fashion or on their own as well. So Julian, would you mind sharing us a little bit about your most recent endeavors?
Absolutely. So we heard it before. We could soon have a quantum computer that could be used for commercial applications, but only if we really figure out how we can use it for real applications, we were able to use it for value. And some of those most key applications in sustainability are where we really see a strong indication that there are systems that we cannot solve classically are about batteries, they're about new materials for maybe hydrogen, they're about new solar systems maybe, solar panels. And so we have been trying to do the research really to figure out how can we really apply quantum computers in these specific cases. And I would like to connect it to what I think both of you said. So we know that there's this side of quantum computers that is really has a big potential to build new products that benefit sustainability. But we also know that if we use our existing technologies, our HPC, we are likely to use much more energy than we can afford to spend on those cases, right? The current way of scaling up large language models and number of parameters is unsustainable, and we have to come up with new ways. Now, quantum computers, of course, provide a very big opportunity to do so. I'm not sure if, in the end, the net energy consumption will really go down compared to where we are now. It's like building new roads. In the end, we'll just drive more. But what it does mean is that we're able to get further than we are today. And if we get further and develop these applications, such as batteries or solar panels or other things, we really are able to contribute significantly to sustainability.
Indeed, thank you for that. So building up on this, as you mentioned, high-performance computing environment will play a key part in at least, very least, the foreseeable future in the integration of quantum computers. So I wanted to attack this from a slightly different angle and touch upon another key topic that we at Pasqal take to heart, especially when it comes to optimization problems, which is hybridization. So approaching problems from a hybrid quantum classical angle, which in a sense promise some more near-term applications. Meanwhile, they are still missing some key benchmark elements. So Stéphane, would you mind sharing us your thoughts about how you see this hybrid quantum classical approach evolving in the near future? What are the actions that are being taken here in France or in Europe?
Yes, so I just told that we just started our quantum journey. In fact, after the announcement by the French president of the quantum strategy, we, so CA, INRIA, and Genci have been charged to implement what we call HQI, the French HPC hybrid quantum initiative, with the idea to couple traditional computers with quantum devices acting as accelerators. So we think that in the near future, quantum devices will help to accelerate, like it was the case with GPU in the past. If you remember, the first time we coupled GPUs, it was very difficult to program them. We programmed them with video games, language models. It was very hard. So we are at the same level. But we consider that in the future, this quantum device we could have as accelerators, and there are many fields, it has been touched by Elvira, in which quantum computers could provide in the future an acceleration, meaning, for example, in quantum chemistry, meaning in optimization, in machine learning. It's important for you to recall that, for example, in the daily production of computing centers, I will say chemistry with a big C is representing 1/3 of the cycles we burn on supercomputers. So if we are able to outsource, offload part of this production on quantum devices, we are going to provide much more sciences while reducing the carbon impact. So we started with emulators. So we are playing with Pulsar, with Captiva from Eviden. But now we are very pleased to be the first customer, the first physical customer of Pasqal. So we are currently installing a system at CEA. It will be operational during this autumn. So it's a very long journey. We are learning by working because it's not so simple to have a machine coming from the lab to a real production center. So this is the job we are doing now with Pasqal. I'm very happy about the collaboration we have with your team, Georges. So this autumn, we are going to provide a first device. We are going to provide the second one based on different technology because the mission of HQI is to provide as many QPU as we can, to expose them to the users in order for them to assess the best fit between the algorithm and the hardware. And when I say we, I say in France, but also in Europe, because we have the same vision in Europe. It's important for you to recall that in the quantum world, there are 10 technologies available. And Europe has a chance to master 7 to 8 of them. So it's a chance we cannot miss. So with our colleagues in Europe, especially, for example, our colleagues from Germany, from Italy, from Spain, and for Finland, for example, we are collaborating for making available as many QPU as we can for users, from academia, from industry, in order for them to prepare, to change their algorithm, to think quantum. We used to say to think quantum because it's really a way of thinking, and to pave the path for future quantum advantage, either in performance, either in energy.
Yes, so thinking about quantum, I believe last year during our quantum hackathon, we have seen some very promising different use cases that were proposed by the candidates during the 6-week-long competition. So Etienne, as you have followed through the whole process, what were the problems that stick to you the most, and what were the surprises, positive or negative, that you would consider the key takeaway messages of this hackathon?
Well, I think the first surprise for all of us is that we had a wealth of proposals from all over the world, and we actually worked day and night, including you, because there were so many proposals, so many people attracted to say, well, let's do this the right way, let's find a truly sustainable use case, and let's try to put it right now on Pascal's technology, and let's try to check the energy consumption. So it proved to be a very attractive promise, attracting people from all over the world to work day and night for a very improbable success. So for me, I think it's a very nice signal, because of course now the roadmap is long before proving this hypothesis. But if you have very strong enthusiasm at the beginning, then that's a nice piece of news. Now, if we look more into the detail, we had, of course, things regarding drug discovery, not unsurprising. And then we had things about renewable energy that was very interesting, and also optimizing sustainable transport. We had also optimizing energy grids and something, of course, electrical vehicle charging networks, and also water resource optimization. And so quite a large amount of sectors. And then if we look a bit more technical, it was quite interesting to see that people would quite quickly switch into hybrid architecture, and sometimes already, although very small, coupling AI and quantum computing in a sustainable use case, which is rather nice news. We stick together very, very fashionable things, but it was not only fashionable. I mean, it was truly convincing, and actually the use case that won the prize was about renewable energy, matching AI, let's say rather simple AI, but AI and quantum computing. So that's very encouraging, I think. Now, of course, there was a lot of debate because it's difficult in a so short hackathon to be very sure about the energy metrics, because it's all about extrapolating things on very so yeah, there's a lot of uncertainty, but at the beginning of a long travel, there is always uncertainty.
Yes, indeed. As we have seen, and there were quite a few use cases where it was debatable how, especially in the long term, the energy efficiency can be proven or guaranteed. And as you have alluded to this, Julian, there are quite a few use cases where it's quite hard or even infeasible to guarantee such advantage. So the attention should be brought more towards utilizing more efficiently these different available quantum resources. And for that, I believe one of the key ingredients is having a more strategic mindset and bringing the right actors, the right players around this proverbial table. So the question I want to ask you is more about the ecosystem, since you have been actively present for the past couple of years in various forums and various domains and fields. So how do you see the evolution of the quantum ecosystem as a whole, and how do you feel about its potential heading towards a greener future?
Yes, thank you. So the ecosystem is very much in development, and we heard it before. It takes a village to raise a child, I think was one of the analogies, but there are so many different technologies that have to come together. There's dozens different hardware technologies. There's many different parts of the stack that are crucial to make quantum computing applications work. And no one can really address all of those challenges alone, right? There's many different things that have to come together. I think that there's two sides of the equation. There's the end users that should get more specific and really have much more focus on not just what use case do I have, like drug discovery, boiled down to specific molecules, specific reactions, specific data. On the other hand, the industry, the quantum industry, should move upwards and think much more about, okay, just a ground state solver, for example, is not going to be enough. I need to think about how this translates into real problems that matter. And I think the industry is progressing towards that. We are starting to close a little bit that gap and having people that are more able to speak to each other. I think there's new companies that are trying to jump into that gap, and new academics and other institutes. And also there's, just by seeing here today, there's loads of end users that are not new to quantum technologies anymore, but have done experiments, that have learned something already and are able to speak a little bit the language of quantum computing. So I think over the next few years, the key challenge is to move beyond the generalities that we sometimes hear about very high-level use cases, but really to boil down to specifics. And it's going to be a challenge because we know that quantum computers won't be, and especially in the next foreseeable future, in the next decade, apply to anything. So we have to get very specifically, what are we really talking about? And I think together with the ecosystem, that's really where people are going.
Thank you very much for sharing your thoughts. As we are nearing the end of this panel discussion, I would like to ask one final question to all three of you. So what would be the single takeaway message with respect to quantum and sustainability that you would like to share with our esteemed public?
Yeah, I would say the quest for sustainability with quantum is really a community thing, and we have to be all together, and I think that's one of the proposals of the white paper. It's a big issue, and we need a community to tackle it.
I will be on the same line. So if you really want to assess, to be part of this community, you can come to us and try our systems or emulators. We can also link you with quantum startups and make real proof of concept. So don't hesitate to contact us. And if I may use my time, during Vivatech, the largest IT conference, we'll have the only quantum booth available here. So I invite you to come on the Quantum Village by the HQI, and we'll meet all the French and European quantum ecosystem.
So I would say that the most exciting thing about quantum computing is the things that we can do with it, or maybe even the things that we haven't really thought of yet that we will be able to do. But the only way we can do them is if we also do that energy efficiently. Otherwise, it would not be a sustainable path forward.
Thank you very much for that once again. So Etienne, Stéphane, and Julian, it has been a pleasure. Thank you very much for your attention as well.